Hello, today we are going to discuss about atomic and molecular structure. Learning objective is to understand the features of hybridization and to predict the type of hybridization of the central atom. If you look at this sheet where we can see if the number of pairs will be 2, then the proposed geometry will be linear. If it is 3, then the expected geometry will be trigonal planar. 4, then tetrahedral. Number of bond pairs will be 5, then proposed geometry is trigonal bipyramidal, and if it then the proposed geometry is octahedral. Now what is the concept of hybridization? As hybridization is based on mainly two features. What is that? The phenomenon of intermixing of orbitals of slightly different energies so as to redistribute their energies and to give a new set of orbitals of equivalent energy and shape. Now these new orbitals which are going to form after mixing, they are known as the hybrid orbitals. Different types of hybridizations are possible. Few of the examples are sp, sp2, sp3d, sp3, sp3d2, etc. Now, how the hybridization is taking place. First example, like one of s orbital is going to overlap with one of p orbital and it will result in the formation of this sp hybrid orbitals. The second is the central atom is boron, which undergoes the sp2 hybridization, and in BH3 we can see that due to the sp2 hybridization, 3 hybrid orbitals of boron, they are going to participate with the 1s orbital of hydrogen atom and resulting in the formation of 3 bonds with 3 hydrogen atom, and the geometry will be trigonal planar. Now, some features of hybridizations are, which are as follows. The number of hybridized orbital is formed is equal to number of orbitals that get hybridized. Now, these hybridized orbitals, which are always equivalent in energy and shape. Before hybridization, their energy will be different, but when these orbitals undergo hybridization, their energy will remain same. Now, once the hybrid orbitals will form, how they are going to arrange around the central atom, it depends on that the minimum repulsion is going to occur. The hybrid orbitals are directed in space in some preferred direction to get the stable arrangements. If two hybrid orbitals will be formed, then the two hybrid orbitals, they are going to arrange in a diagonally opposite direction, which will result in a linear geometry. Same if 3 hybrid orbitals will be formed, they are going to occupy the 3 corners of the trigonal planar geometry. The hybrid orbitals are more effective in forming stable bonds than the pure atomic orbitals. Now, the important aspect is how we can calculate the hybridized state of the central atom. Now, this prediction of hybridization of central atom is calculated by using a formula. Before explaining the formula, we can see what are the symbols involved in this formula. The first symbol is H. This H represents the hybrid state of the central atom. Second, we have to find out the number of surrounded atom or groups, and these surrounded atoms or groups are represented by the symbol S. Next is the number of outer shell electrons in the central atom in the ground state, which is represented by symbol E. Now, these surrounded atoms may be univalent or a bivalent. So, if it is univalent, we can write the valency is 1. And if it is bivalent, the valency is, we can write 2, and the symbol to represent the valency is V. Find the electric charges if species is ionic, which is represented by the symbol C. Now, this is the formula to calculate the number of hybrid orbitals. H is equal to S plus 1 by 2, E minus V plus minus C. Here plus minus C represents what is the charge which is present on the ion, positive or negative, S number of surrounded atoms, and H we are going to find out the hybrid state, and V is the number of valence electrons. Now if we will calculate the value of H, if it comes 2, then it indicates the type of hybridization is sp. If 3, then sp2, 4 sp3, 5 sp3d, 6 sp3d2, and 7 sp3d3. These are the some examples by using this formula. First example is how to identify the state of boron atom in tetrafluoroborate ion, that is BF4 minus. By writing this formula, we can substitute S, that is the surrounding atoms, 4 fluorine are there, E, that is the number of valence electrons which are present in the outermost shell of boron, is 3. Then V, because the 4 univalent fluorine atoms are there, so we have substituted 4, and the C, that is the charge which is present on the ion, which is equal to 1. So by substituting the value of S, E, V and C, we can calculate the number of hybrid orbitals will be 4. That means the boron will undergo sp3 type of hybridization. Same way we can calculate other examples like sulfur in sulfur dioxide by using the same formula, H is equal to S plus half E minus V plus C. Now other examples like methane, CH4, as we know carbon atomic number is 6 and the number of electrons which are present in outermost shell is 4. Carbon, which is surrounded by 4 hydrogen atoms, so we have written S is equal to 4, E, that is 4, valency, number of valence electrons 4, and we will find that the hybrid state of the central atom will be sp3. Same we can calculate for so many ions and the molecules. Now after discussing this formula to calculate the hybrid state of the central atom, we can easily predict the type of hybridization that molecule is going to show. Based on the type of hybridization, we can determine the geometry of the molecule. We can determine the bond angle which is present between the atoms in a molecule. Now the learning outcome is that what we have understood the need of hybridization. We can easily calculate the type of hybridization of the central atom, and as well as if we know the type of hybridization, we can easily predict the geometry of molecule. Now these are the questions which are generally asked in universities examination for multiple choice questions. The correct order of hybridization of the central atom in the following species. Now here we can see NH3, PCl5, BCl3. Then we have to find out that what is the hybrid state of the central atom. In NH3 we have to calculate the hybrid state of nitrogen. In PCl5 we have to calculate the hybrid state of P, and for BCl3 we have to find out the hybrid state of B. Then second question, an octahedral complex is formed when the central metal ion undergoes hybridization among dash orbitals. So if we know the type of hybridization, if we know the number of hybrid orbitals formed, it is very easy to predict the type of hybridization, that is octahedral, that means the surrounding atom should be 6, and very easily we can predict the correct answer will be sp3d2. Third question, the molecule that has linear structure is. Now linear structure is possible when we can see the type of hybridization will be sp when the two hybrid orbitals are going to be formed and they are going to overlap with the other orbital of other atom, surrounding atom, then we can see the geometry will be linear. These are the some descriptive questions. It depends upon university We can design these questions based on the marks like 3 marks, 5 mark question, or maybe in a descriptive, if you are going to combine 2-3 questions, it may be 8 or 10 marks question. Thank you.